That's weird. Why is this camera off? Okay. Stop that video. Is it 2? I am showing it is 2 o'clock, folks. My name is Brian Hutchison. I'm going to be your fearless leader for the next hour or so. And I'm not, how do I want to say it? I'm not good at picking those topics that, for workshops that get people in. But if I were going to ask you, right, to think of your favorite word that starts with F, keep it to yourself. I need PG-13 in here. My bosses are in here. But seriously, think of your favorite word that starts with F. Now, I won't bet any of my money, but I'll bet some of y'all's money that it is not the word factoring. Raise your hand if you've heard the word factoring before in your life. Right, great, most of y'all. How many of y'all love factoring? Well, I would have lost all your money, right? It's probably not your favorite word, right, that starts with F. I'm hoping it is fun or Friday or something of that nature. So, before I go any further, why should you never pick a fight with a pirate? What? They have a mean left hook. No? No? They have a mean left hook. So I promised that I wasn't going to make a strong math background a priority for today. And Dylan, since I see that you are online, could you do me a favor and maybe in the chat or something, send me like your name, V number, and your math professor. That way I can get you added to the list and get any credit that you might need. So I want to start with another story. Yes, ma'am. You can, before you walk out, there in the back, but right now you're good. Just do it before you walk out. So I got another question to ask. So my question is, why, oh, why do we always make you factor? It is one of our basis operations in your toolkit, right? For all of your mathematics, usually on the algebra side, is to do factoring, right? Does anybody know why we make you do factoring? Why is it important? Okay. Good, right? So I've got a story to tell you, and this is how I feel about factoring, and it's a lifelong lesson, right? But let's say I am your boss, right? Y'all work for me, and I give you a job on day one, and I'm like, we need to cure world hunger. Yes, it is. Ken, sign in, find a seat, come join us. Seriously, day one, I hired you, right? And I ask you, I need you to solve world hunger. What do? Might be first start.
Where's the most food being wasted?
I like that. Anybody want to know what I would probably do? I overthink everything. I might quit. Y'all laugh, but right, that's a serious friggin' job. It's a big job, right?
That
it is a tough job and it might not be doable. Why would I be in a job where every day I know it's going to probably fail? Well, I heard delegate and some ideas of chipping away at the stone, right? Factoring is a big stone, it is a big thing, but what factoring does in general is it breaks the big ugly thing into smaller pieces. And those smaller pieces represent the big stone, right? It represents what's going on. You come on in, Yahoo. They represent that big stone. So maybe as a better boss, instead of saying, hey, it's your job to cure world hunger, right, maybe I should do it in little bitty steps. What if I told you, hey, the first job for you is I need you to find all the food banks within a 200-mile radius of this stretch? You should be saying, man, that's doable, man. I only need a day for that one. And then I start asking you, hey, where are these food banks wasting food? Or how do they get their supplies? So on and so forth. We break it down into little bitty steps, and those little bitty steps are all tackling our big issue of trying to solve world hunger. So I don't know about y'all, but let's talk about something a little bit easier, right? Maybe English class, 5-page paper. Anybody can just sit down and write a 5-page paper from scratch? No, I had to plan. I had to go get resources, so on and so forth. But that's like factoring, folks. We need to take that big job and break it down into manageable pieces. And luckily, those manageable pieces, A, seem easier to us, right? But they are all related to that big stone, that first big stone. And that's what factoring is doing. It takes something bigger, right? Something uglier that we might not know about, right? And it breaks it up into its pieces, and those pieces are easier for us to comprehend. But that might be factoring part 2, and I'm getting a little bit ahead of myself. But like I said, I want to play with factoring, right? And before we do that, I think I'm going to start backwards. So I'm just going to take two little things, say 2x plus 1, and I am going to multiply it by an x minus a 3. These are two little pieces. How many of y'all are in college algebra? So if I put y is equal to 2x plus 1, at this stage of the game, y'all should recognize it, right? That would be a line. Now, mind you, I'm not having a y yet, but if I just looked at 2x plus 1 and set it equal to y, y'all be like, man, that's a line. And if I had y is equal to an x minus a 3, y'all would say, well, that's a line. I have just witnessed that in the last 2 to 3 days of college algebra. But this is different, right? These are two pieces. And this is not, right? This is not factoring yet. So what I want to do is I want to perform this multiplication. Anybody know what I should be doing? Anybody like the other F word?
How about an F word, distribution?
Distribution, I think you and I are going to get along. I don't like this other F word. It's called foiling. It only works for basically a binomial times a binomial, but all it is advanced distribution. And I always like to show my hops, right? So this is multiplication in the middle. So 2x times x is 2x squared. And then when I do this guy times the last guy, that's basically a 2x times a quantity of negative 3. What's 2x times a negative 3? Minus 6x. Now, I'm going to use this technology, right? And I'm just going to highlight these two things right here for you. And I'm going to put a little line right there. That's what I did. And then I'm going to take this 1 and multiply it by an x, and that gets me to what? 1 times x, which would just be my x. And then do 1 times a -3 gets me a -3. And I'm going to use a different color. So these two things really came about from the distribution of 1. Here's where I got to have a little bit of faith from you, right? If I do basically commutative rule, everybody know what commutative rule is? Everybody agree that commutative has lots of m's in it? Not shooting gang signs, this is just my m, right? Commutative and m, right, looks like this, and it looks like this, right? 2x plus 1 is my first finger, times, and my x minus 3. Commutative rule allows me to do this guy, right? I could say x minus 3 times the quantity, the 2x plus 1. But what if I would have told you if we would stop right here, factoring wouldn't be the big F word? Seriously, if we stopped right here, factoring would not be any problem in the world. And I still really haven't even showed you a factor problem, but I'm telling you, if we stopped right here, the big part of the game would be over with. Right? We wouldn't be afraid of factoring. We wouldn't have had bad experiences with factoring. If I could stop right here. But we have this crazy thing called simplification. Now, if you notice, go back to my black pen, is I have some like terms in the middle, right? -6x plus an x, they're both x terms. My wife likes to raise chickens, folks. And sometimes when I'm talking about addition, addition can sometimes lead us into more danger than multiplication can. Multiplication is usually pretty nice in general, right? Especially from a professor standpoint. I see less errors, but this guy, right? My wife's chickens, right? She lost 6 chickens and I found 1 chicken. How many chickens are still missing? 5, right? That's all this says. If you don't like chickens, we can talk about country dancing, right? That's 6 steps backwards and 1 step forward. I would still, right, be backwards 5 steps. So this is foiling, distributive rule, right? So on and so forth. This guy is different to y'all, right? Especially 13, 14, one of our big target groups at the moment. This is different, right? It doesn't look like it's pieces of lines. It's an x squared. And I don't know about y'all, but my students, I warn, if I start seeing x squareds, y squareds, et cetera, that we are not actually talking about lines anymore, right? But I gotta warn you, this stuff is coming. That's why we picked factoring, is because factoring is coming. So what is factoring? It's doing the opposite in the reverse order. Right? We start with this new big thing, which is a trinomial, right? And we have to break it apart, right? Such that we get it into its pieces. That's it. That's what factoring is. And by breaking it apart, the little pieces are less scary. And all it really is time and process management. Right? By breaking something down, our lives get easier. Oh, but we take a deep breath, right? And I'm 13 minutes into this and we still haven't really done factoring. And that's okay, right? We always got to build up and know our enemy first. And here's where I got to warn you. Right? There are about 4 ways that we see that different people will factor in different ways. Some of them are mathematical bull malarkey, right? if you do it a different way, y'all need to go ask your professor, right? Come ask me, show me the way you learned how to do it. But in college, it doesn't fly. And I'm going to tell you how I was taught. I was taught by, hey, there's a pattern and juggle that pattern, juggle those numbers in your head until it all works out. It took me a while. It really did. Now, mind you, I juggle numbers pretty well, but anybody here, can you juggle numbers in your head well? Right? It's not y'all's fault, right? It's society's fault. It's other things going wrong. But the biggest thing is I need multiplication rules from you, multiplication tables, division tables, et cetera. That stuff was taught to me, and a lot of y'all got robbed, right? It's not a big deal, right? It's just that times have changed, so some of the methods of teaching factoring have also changed. And I'm going to show you the one that is most related, right? And to actually doing mathematical processes without juggling numbers in our head. So everybody ready? This is going to be the first one we tackle. It's a middle of the range problem, et cetera, et cetera. So our first step, right, would be getting to right here. So the method we use, right, it's actually a combination of methods. It's called the AC method, right, and it's called factor by grouping. So first, AC method. So I've got to explain this quadratic. It's one of our primary targets, right? We see quite a bit of it in 1314. All of y'all that took oh my God, the TSI-A, which is the TSI assessment, I promise y'all had factoring on that test, period. So I have to tell you that a quadratic, which is what this guy is, we usually have a form, why did I write 5? The plus bx plus c. And what happens is we need to do something called the AC method, and it's A times C, folks. And in this case, it is 2 times a -3. Because my A term is a 2 and my C term is a -3. Notice the sign change. All right. Well, this gets me a number of -6. So when we built this, we said we don't need you to have a high math background, right, to come to this deal. And I promise you, I'm going to try to keep it as simple as possible. But anybody know what the divisors of 6 are? So 3 divides into it, but think of it as a pair. It's 2 and 3. Right? It also could be 1 and 6. And I hate to say it, but a lot of times we'll ask for the factors of 6. And I'm not worried about the negative at this point. I'm not worried about the negative at this point. I need to do a tree. And some professors do this tree differently. If you came from the high school, I've even seen some people use boxes, right? But the boxes get really big, but man, I'm all for anything that helps you coordinate. So what we have to do, folks, is it's really that combination that we did. It's that -5 is the enemy, right? I need to split -5 into 2 pieces. And I can split -5 into a 1 and a 6 or a 2 and a 3. But I'm going to tell you right now, to get the 2 and the 3, what has to happen? If they were both negative, they have to add up to -5. I'm going to take a big step back. So what is my goal with this method? This is the heart and the soul of this problem, folks. It's the AC tree. If we can get the AC tree correct, factoring's easy. Because if we get the AC tree correct, we get back to 4 terms. And I told you, factoring wouldn't be the big F word if we had those 4 terms. So it's the factors or the divisors of the -6 that add up to that -5. But this one's special. This doesn't happen often, but if I had a -6 and a +1, that would add up to a -5 also. Question is, one of them's right and one of them's wrong. So the only thing we haven't done yet is, remember, it's a -6. Does -2 times -3 give me a -6? 2 negatives multiplied together give me a positive, right? That guy cannot be it. And all I have is one warning for you. I need those divisors to add up to the B term, the middle term. And secondly, I need them, right, to make dang sure that the signs match up such that they get to my AC number, which is A times C. And what's neat, right, is if I scroll up just a little bit to kind of tease you a little bit, look what's happening here. There's that -6, and if I put a 1 there, there's that 1. So using a secondary process, I was able to pick how to break apart the 5. Yes, ma'am.
So the divisors need to, -6 needs to add up to the AC
B term. They need to add up to the B term.
to the B term.
Yes, ma'am. So if you notice, I like to split things up. I call this my dog leg, right? I need to break this guy up. But the nice thing is the 2x squared and your -3, folks, those things weren't that hard, right? They weren't that hard. They didn't combine with anything. It's that middle term that's evil. Well, what is it? I can write it by putting some little X's here, and I have split it. But what do y'all want me to put down first? Do y'all want me to put +1x minus 6x, or do you want me to flip it?
-5.
Well, I got to break apart that -5. So do you want the 1x? Just what I wanted y'all to do. Now, please note, right, how we wrote it. So I just used what I got over in my AC tree is slightly different than what we got up here. Everybody agree? So here's where after this, I need 3 steps from you. It's basically 3 greatest common factors, right? But this method is called factor by grouping, right? So I need to group some things. And basically, if you have 4 things, are you allowed to group these 2 and these 2? Nobody wants to fall into my trap. No? You got to be careful. We're talking about associative group. I can group things together usually with addition and multiplication. Those are our nicer ones. Subtraction throws a little bit of hissy fit into the entire mess. And we see a lot of errors in math class, and it's not a bad little rule, right? So my way, and I'll show you another way, is that minus sign in the middle is plumb evil. If you're taking notes, what I'm fixing to do is wrong. This guy, it's safe for me to throw up a pair of parentheses, all right? That's my group. I took 4 things and I put the first 2 together. Is it okay for me to do this? No, right? A minus sign in front of a parentheses is not in your best interest, right? It changes up the problem. That -3 is now a +3. So you have to have a little rule, and I just say, I need a plus sign in the middle, right? It's plus a -6. That's all subtraction is the addition of the opposite. If that's a plus sign, then you can throw up your parentheses. And all we have to do is find the greatest common factor. So let's say you hate that method. Right? Some people don't like it. It's okay. But remember my colors up above? These were all linked together. And these were linked together. We could do it without throwing up our parentheses, right? We're still grouping, right? But my first question is, what does 2x squared plus x have in common? They only share an x between those two terms. Instead of looking at 4 terms, I'm only looking at 2. It makes my job easier, right? So if you pull out an x, what's left over? Careful. X divided by x is 1. So basically what we're doing is a form of division. What is -6 and -3, or I should say -6x minus 3, what do those two pieces have in common? So 3 is one answer, right? But I want my x to be positive. So let's pull out a -3. What's -6 divided by -3? 2. The x didn't get played with. What's -3 divided by -3? +1. Check it with multiplication, folks. -3 times 2x is -6x. -3 times 1 is -3. It has to work. But here's something beautiful about this procedure, right? You should reward yourself. Smiley face, right? Firecrackers going off, something. Because there's not that many operations in math that halfway through says, congratulations, you're on the right track. This has a tattletale that says, congratulations, you're doing a good thing. We have 2x plus 1 in both parts. Not cross them out. I can still factor, right? I said I needed to factor 3 times, greatest common factor. First, we pulled out the x, then we pulled out the -3, and guess what I'm doing in the end? I'm pulling out the 2x plus 1. If I pull that out, what's left over? X minus 3, and that should be what we started with. Cute. Right? This is the nasty part, but if you can follow the rules and get the AC tree right, 1, 2, 3 steps. That's what I'm going to try to promise you today. Yes, ma'am.
Can we go back to the part where you pulled out the 3, that's, you divided like 3?
So when I factor out, I'm basically doing division. So if I had 2x squared plus an x, what I am doing is I am basically doing division, right? I'm trying to steal an x out of there, which would get me to 2x squared over x plus an x over x. And have you ever seen this playing Army, right? If you have one soldier on bottom and you have 2 soldiers on top, one of those soldiers goes away. So you get left with the 2x, and then x divided by x is 1. That's all we're doing is division. So I'm trying to break factoring down without juggling too much into multiplication and division. But this method over here, folks, like I said, if you don't want to remember, hey, there needs to be a plus sign in the middle, what does 2x squared plus x have in common? It still has an x, and you get left with a 2x plus 1. What does a negative 6x minus 3 have in common? Well, they both can be divided by a negative 3. Negative 3. Which would leave me with a 2x plus 1. And that's the same steps. So let's go harder. So what if I had 2x squared minus 28x plus a 96? So we don't know the answer starting off on this one. But I want to show that this is one iteration, one step harder than the previous problem in certain ways. So this is our first true blue factoring problem. Period. And so I think I need another jump. So does anybody know the name of the bulletproof Irish guy? He's a superhero, but he's bulletproof and he's Irish. His last name is O'Shea and his first name is Rick. Rick O'Shea? Ka-bing! Kaboom! No? I like that joke. Right, we can't be too serious. This isn't a true class. We're just trying to help ourselves a little bit, right? So there's one step that I want to give you that could make or break you in factoring. So if you tried the AC method right here, right now, you would have to do A times C, 2 times 96, folks. Does everybody agree that's a big number? And does everybody agree that that's also going to be what? A lot of factors, a lot of divisors, right? Do these numbers have anything in common? They're even, which means I can do what? I can steal a 2 from every one of these. So I'm going to factor, right? Pull out a greatest common factor of a 2 out from the beginning, right? Which would leave me with x squared minus a 14x, and half of that, guys, should be 48. But this part is already done. I like to draw a little arrow. Right? I don't want to keep it in my problem, right? But I also don't want to forget about it. That 2 is very important to me. I need it. If this was an equation, which is a totally different workshop, that 2 is trash. It's gone. Right? It doesn't matter. But here, my A term is 1, which makes me very happy. My C term is a 48, and 1 times 48 is, well, 48. Which is a whole lot better than 2 times 96. So this first step is something that you should have had in your past, right? And I might even be able to show you some secrets. My first warning is, how many of y'all are true blue calculator users? It's okay to raise your hand. Anybody like hardcore calculator users? Well, I need you to be careful using the calculator here, right? I've seen it way too many times, taught way too many students. You sit there and you do 48 divided by 1, 48 divided by 2, 48 divided by 3, 48 divided by 4. And by the time you get done with it, you forget what in the heck you're looking at, right? It's just a problem. Write stuff down, right? So does 2 go into 48? the beauty of this is if you double 1, you get 2, which means on the other side, what's half of 48? Half of 4 and half of 8. Does anybody like that trick? I double one side, I half the other. As long as they're even, I'm telling you, I can get numbers down really quick, folks. That's the part of this thing. Well, quickness isn't the part, right? But getting numbers down. If I double 2, I get 4. What's half of 24? 12, right? Oh, look, I can do it again. I can double 4 to get 8, and what's half of 12? 6. Oh, I can keep going. I can double 8 to get 16, right? Half of 6 is 3. I got a lot of numbers by using just, honestly, a little secret of multiplication by an even. But some of y'all might not like this, right? You could be saying, well, Brian, I know there was a 3 there. Well, yeah, 48 divided by 3 is 16, but I already got it. Right? 5 doesn't work. You know, like, well, I know 6 works. Well, yeah, it's 6 times 8, but I've already got that one. Are there any other factors?
That's the number's a lot bigger. Yeah. Start going to the.
Unless we get to primes, yeah, the bigger the number, the scarier things get. But what's my goal, folks? Do any of these two numbers add up to negative 14?
68.
Ah, but in order for that to happen, I need both of them to be negative, and y'all are finding a pattern, right? If this guy is positive, I either need 2 negatives or 2 positives. That being a minus 14 says that I probably need 2 negatives. But a negative 6 and a negative 8 adds up to negative 14. So if it adds up to the B term, step 1, if negative 6 times negative 8 gives you 48, you're sitting pretty, folks. I'm telling you, the hard part's over. You might be saying, Brian, that shouldn't be that hard. It's not. Right? But if you mess up on the AC tree, it's kind of like pointing the gun at your pinky toe, right? It's probably going to be bad for the pinky toe. We need you to be okay with this. And this is what I was saying at the beginning, right? Some little bitty just, hey, do I know how, what divisors are? Can I get them listed? And please write them down. That's the scary part, is when we see people just, they get to the answer, but they're going so fast with the process of division, right? That they skip right over it. That they skip right over it.
Said the A and C have to add up to B.
The divisors of A times C has to add up to your B term. Yes, ma'am. So now we're just going to repeat what we did up above. Here's my x squared. Here's my minus a 6x. Here's my minus an 8x plus a 48. Anybody want me to switch the 6 and the 8? Because I promise you I can't. Some people worry about that stuff, right? They fight tooth and nail. And I'm just saying, most of the time it's okay, right? Go with your gut feeling. But I'm not going to lie, if I ever get stuck with a positive and a negative, right, of my divisors, I'm going to put my negative one first. That way I can just throw up my parentheses and run with it. But unfortunately here, it's a minus and a minus. So who wants the parentheses method? Okay, then since there's only 2 choices, we're going to do the color method. This and this. So now tell me, what does x squared minus 6x have in common? Now, do y'all feel that we should always be able to pull out an x? I'll let y'all make that assumption. So what's x squared divided by x? Just a lonely old x. What's minus 6x divided by x? Oh, folks, I am telling you, you have so much power right now. I know that my AC tree is correct. Anybody want to bet your money? Not mine. I'm just a poor professor. That we better get an X minus 6 right there? Now, I don't want you to do it quite like this until you get good at it, but I think I should be able to get an X minus 6 there. Otherwise, we might not have a factorable, right, expression, or we made a boo-boo. So what does -8 and 48 have in common?
-8.
-8. The first thing you should always check is, does the smaller number divide into the bigger number? And if I pull out a -8, all right, I can check it. -8 times x is -8x. -8 times a -6 is a +48. What do I do next? Trying to feel like Caesar. Do I need to look for knives? What do I do next, folks?
Parentheses x minus 8.
No, you put happy face, fireworks, right? Because it has told you, right? Congratulations, you're almost done.
Bring down two.
Mhm. The 2 is still coming down.
Someone raised their hand.
On the screen, was it Dylan? Was it this one? He's a professor, he doesn't count.
Oh,
So after you put your smiley face, folks, right, I see X minus 6's in common. And believe it or not, thanks to multiplication, I have a term minus another term. So I'm pulling out an X minus 6, right? If I pull out divide by X minus 6, I get left with an X minus an 8. And the last little thing I was going to try to catch y'all on was, well, don't forget that dang 2. I need that 2 until it becomes an equation. If you do anything, right, after this, even though we're only going to do about, I'm hoping to do one more problem, right? Go back and rewrite this, right? Try 2 problems on your own, but keep doing those 2 till you kind of see what do they have in similarity. Because I'm going to tell you, factoring is a big deal. Okay? It's major, right? All the way even into your calculuses, right? Factoring, if I can get you to do factoring, right? Ouch, ouch. I wish I could do that though. But if I can get you to do factoring, if you can master this, right? I promise you, your math life is usually going to get a lot easier. It really is very bimodal. We have the ones that can factor and we have the ones that can't factor. And it's freaky, the correlation with the people that can factor, not just succeed in the rest of their math classes, right? But they're usually good with things like time management, right? Breaking down processes, planning, et cetera, because y'all have all heard it. It's not always about the math. It's about the way that we are training your brain to think through a process, right? And we're breaking these things down. And the last one, it's not meant to be hard, right?
That's the answer with the 2 on the outside of the parentheses.
When you factor, that is our answer. Yes, ma'am. So last but not least, so my first problem we worked backwards, right? And there was a 2 in the A spot. The second problem I gave you, there was a 2 in the A spot, all right? But I pulled out a greatest common factor and I got a 1 in the A spot. We usually like the ones better. Like I said, this is introduction into stats and to make sure you're not afraid of stats. And we're focusing mostly on the trinomials. But I want to delve into something called number sense just a little bit. And I gotta warn y'all, right? And it's not, this, for all the tutors in the room, this is not supposed to be a negative thing. But some people are better at juggling numbers than others, right? Anybody think that's a true fact? It should be arguable, right, that some people can juggle their numbers better than others. And sometimes in tutoring, right, or heck, even if you come to me, right, a professor, some interesting things can come, it's like, oh, geez, I wasn't even thinking about that, but yeah, I agree with you. Those are my two numbers. No, don't ever do that. Don't think it's hocus pocus. Don't think that somebody's Houdini. Ask them, like, why in the heck did you think about those two numbers? Why did you think about those two numbers? And with this, I want you to think about those two numbers. So this one's nice. It starts with a 1. It starts with a 1. So my A times my C, 1 times a negative 72. That's easy. It's negative 72. So not divisors, but tell me everything you know about 72. It's even, all right? Since you said that, I'm going to pick the easiest divisor, which means if I double this one, I can half that one. Does everybody agree it's 36? All right. Half of 70 is 35, half of 2 is 1, so 35 and 1. What else is special about 72? What's special about 108? What's special about 224? Or no, 225, excuse me. 225 is 72, ain't though. All their numbers add up to 9. If the numbers add up to 9, they're divisible by 9. Period, right? 1 plus 0 plus 8 is 9. I promise you that 108 is divisible by 9. Easiest one is it's something special because we have 10 fingers. And if you wanted to do like 10 times 8, you got rid of a finger. So now I have 9 fingers, but you get 72. That's basis, and that's a whole other string of math, but some neat things happen, right? With 9s. And I'm not going to lie, 2 and 36 could be what we're after. It could be, but you will be shocked usually once you start to look for patterns in numbers, folks. Y'all know what makes an even number, right? Everybody should be giving themselves a pat on the back when we started saying, oh, that's an even, right? We pulled out a 2. It made our lives a lot easier. I dare y'all to all go back and tackle the original problem, 2x squared minus 28x plus a 96. The problem would have been a lot harder, and we would have said another favorite F word. Pulling out a 2 made it easier. And if I can get you to start picturing certain things, right, that, you don't have to do it, but if I double the 4, I half that. And then if I double this, I should be able to half that. It's a trick of evens. But I know that 3 also goes into this thing. It should be 24 times. But does anybody know how I got 3 and 24 works? I didn't even think about that. I did 8 times 9 and then said, well, 9 is 3 times 3. Well, 8 times 3 is 24. I did not do 72 divided by 3 in my head. I just borrowed a 3 from the 9 because I've been teaching you to borrow a 2 from that side. Why can't I borrow a 3? It's all about getting these numbers down fast, but it's not the point of this deal. But if I can get you a little bit faster, you have more time for the harder problems on your 13, 14 test. And we all need extra time. But anyway, what's my magic number? A +1. Are any of these numbers 1 apart? I need a +9, a -8 to get me to a negative, oh, excuse me, not -72, to get me to a +1. They add up to +1. They multiply to a -72. Game's over, folks. X squared minus an 8x plus the 9x minus the 72. I split that problematic term into 2 pieces. And then after that, it's the same 3 steps all over again. So what does this have in common? An x, right? So x squared divided by x is x. Negative 8x divided by x is -8. This has a 9 in common. So if we pull out a +9, that'll leave me with x. And what's -72 divided by 9? It has to be -8. Smiley face, fireworks, something, folks. All right. If this doesn't match this, we've made a mistake or it's not factorable. But does everybody agree that there is a lot of emphasis on doing this part right and doing 2 checks? It has to add up to the middle term and they have to multiply to the AC term. If those 2 checks work out, factoring doesn't have to be scary at all. But last but not least, we pull out the x minus the 8. And we get left with an x plus a 9. And if you're my student, I hate to tell you this, but I always save this for dead last. Since y'all are not my students, I'm going to tell you that you already kind of knew that this was going to be the answer. Does anybody see that there is a -8 and a +9 somewhere else in our formulas? It's a shortcut, folks. Right? But the dang shortcut only works when the A term is 1. How many of y'all think you're going to have a lot of A terms being at 1 on your college algebra test? I don't like, oh, if A term is 1, I can just come up here and do x minus 8, x plus 9. It's a shortcut. I don't like shortcuts. All right? Because if that thing changes, and I go back to our very first problem, right? This 2x squared minus 5x minus 3, and you try to do the shortcut with that guy, I hate to tell you, but it's almost all wrong, right? Almost no credit. What's wrong with doing an extra 3 steps, right? Pulling out a greatest common factor 3 primes. And I hope you say there wasn't that much bad, right? So I can't legally give you homework, but like I said, I hope everybody takes a few problems and just keeps trying this method. This is the method that you're going to see by most of your professors here at VC when they teach factoring. I'm not going to tell you that if you do a different method, it's automatically wrong. Right? But if it is different, please, please, please ask your professor. Right? There's nothing worse than doing something weird on the test, right? And it being mathematical bull malarkey. That's a hard thing to just swallow, right? It doesn't work so well. So what's the difference between a very well-dressed man on a tricycle and a very badly dressed man on a bike? Attire. Say it fast. Attire. One had one more tire than the other one, and then attire as your dress. Those are dad jokes, folks. Anybody have any questions? All right. I hope y'all learned something, and if you ever just see me,
Name on the list,
say hi.
write your name where we can read it,
Mhm.
put your V number where we can read it. Could you open up a browser?
Open up any browser?
Yeah, I'm gonna show you, there's some more workshops this week. There's another one tomorrow.
Beautiful idea.
Successful in college.
So I put it over here.
I'll show you just a second.
I mean,
It should be on the, if you need your news, go to the bathroom, go to the flush, we'll show you. But, one second.
but they are also shared on the flush too.
They're on the
It's a
flush.
good way to do them. One of them is by a student who's
Oh,
just
shoot,
maybe
I spelled it
about a
wrong.
year ahead of most of y'all.
Yeah, the one tomorrow is by a tutor. Jax Stringham is going to talk about how to be successful in college. That is tomorrow from 11 to 12 in this room. And then there's one on Thursday, RSV, the respiratory illness that especially hard on children. That's going to be in this room again, 12:15 on Thursday. And we have more scheduled throughout the semester. So your teachers may have posted this in Canvas or somewhere. We'll have them on the flush as well. So,
And like I said,
and
Dylan,
that
if
we,
you can send me a chat such that I can get your name and V number and all that sort of stuff. And I can get it to your professor.
everybody signed in, don't leave until you sign in.
But other than that, folks, I hope you stay dry and have a good rest of your day. It's bigger.
May I ask you a quick question about?
Absolutely. You said homework?
Yeah, for your class. It's one question that I can't figure out how to answer, or I feel like I got the right answer maybe, but it's not letting me type it in.
You think it's lying to you?
Okay, it's this one right here.
Okay.
A man drove 16 miles directly east from his home. It's A squared plus B squared equals C squared, correct? Or like this.
And then travel 9 miles north and road made directly. So it's just a distance problem.
Yes, and I solved it like that, and then I got the square root of 337, but I can't, it won't let me type that in.
Okay. So does it say round or anything?
It's 10,
So
and then
you gotta put it in.
square root of that is like 18 something, but then what would the nearest tenth of that be?
So 1 decimal place. So you gotta go to, you look at 2 decimals. 5 or higher, you round. So we look at 18.35. Because we have a 5, that 3 becomes a.
So 18.4. Okay.
So
I was
10.
putting it in.
I promise you on your test. And you put the square root of 337, I'm gonna be pretty good.
Okay,
The, and, yeah.
thank you.
Pretty good. Did it take it?
Yes.
Can you tell me who's over there, who signed in?
It's Dylan. He got off. And all I'm going to tell you is, there it is. It's V000 936 15 Dylan Williams.
Yes, we're definitely missing.
Yes.
I wish they had signed in.
Well, did this last one sign in? I hope it was good. I hope it was decent.
There's one thing I do want to say. My students who did what you did, too, I accounted it wrong.
What to draw the arrow?
Uh,
Wow, that's mean. What's wrong with it?
The line above the line, it should follow up, so I've carried the two all the way down.
I respectfully disagree because it makes the problem so much more complicated.
It's not mathematically correct just to leave it off.
Yes, it is. It is ditto under each single one. Come on, I'm bigger than you.